Hi, and welcome back. Last week in maths we looked at area, and this week we're going to move on to learning about volume. Now, volume and area are a little bit similar, but there's a few differences, so let's go through it. When we're looking at volume, we're talking about the amount of space inside a 3D object. It's really important that that part there, a 3D object, the amount of space that can fit inside it. So last week we talked about, when we first started with perimeter, that perimeter is the length on the outside of the shape. So if you had a farm and you wanted to know how much fence you needed around the outside of your farm, you're looking at the outside. So you measure with a ruler or with a trundle wheel or some sort of measuring tape, and you put your area in centimeters around the outside. Whereas last week we talked about area, and we talked about how much space can be inside it in these little centimeter squares would fit inside it. And that's why our answer would be centimeters squared. Right? And we did length times height, and we would solve that answer of area. This week we're going to talk about volume. Now volume gives it height and depth. Depth is the part where we're going to call it width, height, whatever you want to call it. Basically it's got 3 dimensions to it now. Okay, so now it's the space all inside that object. Fills up the whole thing. So to do that now, we're going to see how many of these little 1 centimeter by 1 centimeter cubes like you use in class, how many of them would fit into that shape. Now that could be a meter by a meter cube. That's a big shape. That's like that big by that. That's pretty big. Now, because we're in cubes, your answer has to be with a 3 at the end, which means centimeters cubed. That's what's the difference between volume is now it's length times width times height. What I mean there is the length times the width times the height. So it's going to be quite big. What I'm going to suggest you do when you're solving it is to solve the length times the width, then get that answer, and then times that new answer by the height. Or whichever way you want to do it, whatever area. Actually, you know, a good example of that would be look at what the numbers are and think about which ones are easiest to times together before you start. Let's look at an example of a cube. Now this cube here has 4 centimeters in length, 4 centimeters width, and 4 centimeters as height. So effectively, if we use this, length times width times height, it becomes 4 times 4 times 4, which can get quite confusing. So what I'm going to ask you to do when you're solving this is to firstly just solve that. Then once you get your new answer, you can times that by 4. So let's just do 4 times 4, which we already know is 16. Okay, now it's the new number 16, the new number, times that by 4. Now you might already know off the top of your head what the answer is, but if you don't, it's fine. You can use algorithm. You could use the double strategy if you didn't know, which double 16 is 32 and double 32 is 64. But if you don't know that, let's go the other way. 6 times 4 is 24. Put the 2 up here. 4 times 1 is 4 plus the 2 is 6. The answer is 64. Now, if you were going to write that in a test once again, I would mark it as incorrect. Okay, because 64 centimeters, you're talking about perimeter, but we're talking about volume. So we're talking about how many little cubes can fit inside that shape. So I want to write 64 centimeters cubed. Okay, so that's volume. I'm going to rip this off, and we're going to go through a few more questions to see if we can sort of change it up a little bit. So let's see how we go. Okay, let's have a look. We've got 2 more questions here to complete before we're finished. The first one is a rectangular prism, and the second one is a rectangular prism, except the second one has a decimal in it, and we'll get to that. But let's look at this one first. There we have a rectangular prism that is 8 centimeters long, 3 centimeters deep, and 2 centimeters high. Now, you know now you've got to do length times width times height, so it's 8 times 3 times 2. Now, all 3 of these would be correct. 3 times 2 times 8, or if you wrote it 8 times 3 times 2, or 2 times 3 times 8. Doesn't matter how you write it, you're always going to end up with the same answer. You might find an easier way for you to do is the easy one first. So you do 2 times 3 first, because you know that one off the top of your head, which is 6. Sorry. And now you do 6 times 8. 6 times 8. And the answer is 48 centimeters cubed. Okay. What I'd suggest is if there is two sides that you could actually do in your head, you're better off doing those ones first and then timesing it and using algorithm only once if you have to. Just like the one down the bottom. With the second one down here, we have a rectangular prism with a width of 3 centimeters, a height of 3 centimeters, and a length of 6.5. Now, if you just go straight out and do 6.5 times 3, and then you have to do a decimal one, and then you have to then find that number and then do another one, you're probably best off only multiplying the decimal place once. So that's, you start with your whole numbers and then you multiply the decimal at the end. So if you start with your whole numbers, we know it's 3 times 3 times 6.5. Now we know what 3 times 3 is. It's 9. And now it's just 6.5 times 9. Now, if you remember from last lesson, that's a horrible multiplication sign, but let's keep going. If you remember from last time with my multiplication with decimals, is to just forget about the decimals for now and just do it like 65 times 9 and then move the decimal place back at the end. So 5 times 9, 45. Put the 4 up here. 9 times 6 is 54, plus the 4 is 58. Now, because we count how many decimal numbers after the decimal place, 1, we go back 1 place and we put a dot there. 58.5 is my answer, but it's not my whole answer because it's just 58.5. It could be kilometers, it could be anything. Even that centimeters is incorrect. You need to make sure, because you're doing volume, centimeters cubed, okay? That's as easy as I can make it for you. Now they're going to get trickier. What will happen is that for the harder side is I'll have 2 sides that have decimal places. That will get a little bit tricky as we go on, but I hope that's at least explained to you what the basics of volume is. And tomorrow's lesson, we're going to go through what happens if we make it composite shapes like in volume last time. That's a horrible drawing, but whatever. So you have to break it up into 2 shapes and solve the volume individually and then plus them together. But I hope that's explained at least the basics of volume to complete today's activity. Thanks for watching.